In this lesson, we're going to look at properties of graphs of quadratic functions. So we've gone through all of the definitions and you've looked at all the different parts and pieces of quadratics. And now let's take a look at an example. So the example here says, identify characteristics of graphs of quadratic functions. For each of the following graphs, determine the equation for the axis of symmetry and draw it on the graph. So for this first part, you're going to want to have a straight edge or a ruler and recognize that it says equation. That's, put a big star beside it, underline it. That's a place where students usually make a mistake because they just write the value, the x value, but they don't write it as an equation. And when we say equation, we mean there needs to be an equal sign there, okay? So if we look at our quadratic here, the axis of symmetry always goes through the vertex, right? I'm just going to write A here and B here. And why I'm looking at B is because B says determine the coordinates of the vertex of the parabola. And the vertex is that either highest point or lowest point of your parabola. And I can see that that's sitting right here. And knowing that that's my vertex, right, that's where my axis of symmetry is also going to go through. So grab your straight edge and draw that line in. Now once you've drawn that line in, you can see the x value that it's going through right there. So it's a vertical line, and we know the equation of a vertical line is always x equals the value that it goes through on the x-axis. And in this case, it's 2. So the equation for the axis of symmetry, I'm going to put it on my graph, x equals 2. And I'm also going to state it here beside A where they're asking us the question. Now, it's going through our vertex here. B says determine the coordinates of the vertex, so that's different. We know the x value is 2, but we can also see the coordinating y value would be 4. Okay, so put that on your graph. X is 2, y is 4. Alright, have a look at C. State the domain and the range of the function. And for a lot of us, this gave us trouble in grade 10 as well. So domain, I always think, okay, D comes before R, X comes before Y. Domain is all possible X values, range is all possible Y values. And I use interval notation. Some people might use set notation. You'll notice our textbook uses set notation. I'm not going to ask you to use set notation, but you need to be able to read it. So when you're checking your answers or looking something up, you need to understand that set notation. If you're having trouble with that, make sure you ask me, okay? So let's take a look at the domain and range here. So recognize, again, when we're looking at our parabola, the parabola is not going straight down, it's going down and out, right? On both sides here. So it's going down, but it's going out as well. So that's going to continue on forever and ever, not only down, but out. So if it's going forever down and going forever out, out is what we need in terms of our x or domain, right? So there's possible x values everywhere here as you go through. So every possible x value. So that means our domain is going to go from negative infinity to infinity. What about our range? Well, I already talked about the limit as far as going down forever, right? And remember, we always start with the lowest possible value. But you can see there is a maximum value. There is a ceiling to this. The topmost y value that we can have is 4. There are no possible values that are greater than 4. So our range would be given as negative infinity to 4. Now, another question you're going to want to ask yourself is, okay, what kind of brackets do I need to use? And remember, round brackets are used when you can approach that value but not equal to that value. Those values are not included. Where square brackets, like this 4, means that we can go up to 4 and include 4. So this is sort of related to, if you think of when we were doing inequalities, right? When we were doing inequalities, if something was equal to that, we had a filled in dot and we were either going greater than or less than. And if it was up to that value, not including that value, we had an open dot. Same idea here when we're talking about domain and range. Square brackets included, round brackets up to but not including. D, determine whether each parabola has a maximum or minimum value and determine this value. Well, we've sort of talked about that with our range, and we're talking about maximum and or minimum value. Remember, we're referring to the y value, right? We're talking about y values here. So if we look here, minimum, well, it goes on forever and ever in the negative, right? Going down forever. But the maximum, the highest possible value is 4. So we would write maximum at 4. Now, finally, E, asking for our x-intercept and y-intercept. And this one's graphed really nicely. You're not always going to have your intercepts sitting at the crosshairs where you can read them nicely, but in this case we do. Now recognize again, with a parabola, you can either have one x-intercept, two x-intercepts, or no x-intercepts. And we'll take a look at all those different possibilities and why they come about. But right now we can see that we have this parabola crossing our x-axis in two places. One's at 0 and the other is at 4. Now look at how I write this. X-intercept 0, 4. The other way you could do this, because the comma throws a lot of students, they start putting brackets around and saying it's a coordinate. That is incorrect. Do not do that. You can write 0 and 4 if you want, just telling me that those are the two spots where our graph crosses the x-axis, okay? Now your y-intercept is also nicely visible here. We go through the y-axis at 0. And we're done that one, okay? If you want to take a look at this next example, you're doing the exact same thing we did for this graph here, where we had a maximum and now we have a minimum. So I'm going to ask you to try this one on your own. Go through A through E. Try it on your own. And then check back in with our notes, and we can go through that together in class as well. But it's a good idea to try it on your own to make sure that you understand what all of those terms mean and how they look when you're given a graph. Alright, let's take a look at example 2. In example 2, we're graphing a quadratic function using a table of values. And if you remember back to when you were first introduced to linear functions, this is the same way you started. Okay? So, given these x values, use substitution and solve for y. Let's try -3. Don't forget, when you're using substitution, you always use brackets when you're putting that in. So I've got -3 squared plus 2 times -3, subtract 3. Evaluate this. I've got +9 minus 6 minus 3, and that would give us 0 for our first one. Now go ahead and do this again for -2, -1, 0, and 1, and you should get values, just for the sake of time here, -3, -4, -3, 0. You should be able to do that on your own and leave that work in there so you can see where that's coming from. Now, you should see some patterns coming up. Even though these x values are increasing by 1 each time, you can see your y values are doing something quite unique, right? But this is a pattern that you'll see always for quadratics. You start at 0, -3, -4, back to -3, 0. So you're seeing that shape emerge, that parabola emerge from your table of values. Okay, let's graph that if I put in those values, put in your dots and then draw a smooth curve through those points. Just remember when you're drawing your smooth curve, right, you're not making a point at the bottom. This doesn't look like a V. It doesn't even look like a U, although it mostly looks like a U. The arms are going out and up, right, and you have arrows on the ends of those. Now it says determine the y-intercept, any x-intercept, the equation of the axis of symmetry, the coordinates of the vertex, and the domain and range of the function. So very much like what we just did on the previous example. So first of all, you can see our y-intercept. You can see it both in our table of values because we know the y-intercept is right here where x is 0, and you can see it here in our graph as well. So that's our y-intercept at -3. Our x-intercept, in this case, we've got 2. How do I know that? Well, I'm looking right here at where my graph crosses the x-axis, and that is at, you can see it in my table too, at -3 and +1. And let's label those on our graph. And we should label our y-intercept as well down here at -3. Now our axis of symmetry, we can draw our straight line, and that's going through our vertex, right? Let's get our straight edge. Once you've drawn that in, you can see that that's going through the value on your x-axis at -1. So that would be the equation x equals -1. So axis of symmetry at the equation x equals -1. Don't forget that's the equation that we're looking for. The vertex is going through -1, -4. You're just reading that right off of the graph. Now the domain and range, that's the last part. The domain again is all of our x values. So looking at this, this is going up and out forever. So out forever means the domain is going from -infinity to infinity. Your range, the lowest possible value is -4, including -4, and the maximum, well, there is no maximum, it's going up to infinity, and that would be a round bracket there. So it's a little bit different. That's instead of being given the graph, you're generating the graph from a table of values given the equation. And we know that if we're given the equation, we could also put that into our graphing calculator. Okay? We could actually put that one into our graphing calculator, and if we do that, we get x squared plus 2x subtract 3. Okay, and if you just zoom 6 on that, you see the exact same graph that we just did, and you'll use the same techniques that we used before to find our x-intercepts and our y-intercepts, and that should be giving us matching what we've just done. The only difference is finding your minimum or maximum value, and when you go in, you go to second trace. You can see if there's a minimum, you choose 3. If there's a maximum, you choose 4. And then other than that, you're doing the same that you did for your x-intercepts. You're doing left bound, right bound, and then guess, and it'll give you that exact value. Let's try this with our next example. In example 3, we're going to locate the vertex using technology. A skier's coach determines the quadratic function that relates the skier's height above the ground y, measured in meters, to time x in seconds that the skier was in the air. Here's the function, y equals -4.9x squared plus 15x plus 1. Graph the function, then determine the skier's maximum height to the nearest tenth of a meter and state the range of the function for this context. Okay, so let's first take out our calculators. You can see I have a different calculator now. And we'll put in the function under y equals. got negative again, remember negative not minus, 4.9x squared. Now, normally that wouldn't matter, but in the calculator it understands that differently. Plus 15x plus 1. Now, when you go zoom 6, you're going to run into some trouble. Okay, so what is the issue here? Well, first of all, they've given us a context for what is going on. You're modeling a real problem. And when we model a real problem, we know that we're only graphing in that first quadrant. So let's change our window. I'm going to just go from -2 for my min x and my y min to do the same thing so that I can see that first quadrant. The other issue is I'm not stretching this graph out to use the most space possible. And that's what you always want to do when you're setting your window. You want to see your graph as best you can so you can see what's going on. So I can't really see that maximum value, okay? So let's change my window greater than y max of 10. Let's try 15. Okay, that works, and then I probably don't need my x max to be nearly as big as it is. So let's change that to maybe 5. And there you go. You're using up more of that space to see what's going on. And by doing that, you're actually also starting to look at your domain and range of the function because you're starting to get a sense of where this graph lives on the coordinate plane. Okay, so how do we get what's going on here? So let's just write something down. We're going to write down the rules for finding the vertex because I've kind of talked you through that already, and then we'll give it a try. Okay, let's go back to the notes. So you go to second, trace, in this case maximum. Is it maximum every time? No, depends on the graph. Let's write or minimum, depending on the graph you're looking at. Okay, and then you're going to go left bound, enter, right bound, enter, guess, enter, and you should get your vertex. Let's try it out. So second, trace. This is a maximum. So I'm going to go left bound, and it prompts me at the bottom. Enter. Right bound, enter. Now those arrows again are on either side of your vertex this time. Hit enter again when it asks you to guess. And there you go. Now we've got lots of decimal places, which is fine. Just round to 1 or 2 decimal places. And we can write that down. So our x value is 1.53, our y value is 12.479, so that would be 48. I'm going to write that down, and then we're going to sketch the graph. 1.5, what did I say there? 1.53 and 12.48. Okay, let's draw our sketch. So there's my sketch. Just remember you need to at least have one point on there to give us some idea of what's going on in your graph. So I've got my vertex listed there. It's also good to put your x and y intercepts, and we can put that in a moment. Now it says our vertex 1.53, 12.48. What does that mean? Well, the 1.53, that's our time. And 12.48, that's our height. And I got that from the graph, right? From the problem. It says height above the ground y, so that's your height, and time was x. Okay, so they gave that right in there. Now the other piece of information I wanted to know is the range of the function. The domain is a little bit different, but what is the range? Well, we know that the maximum height is going to be 12.48 meters, right? Now we're giving units in there, which is really important. And then the range, right? We know that the range is always our minimum and maximum y values. In this case, our minimum and maximum heights, right? So in our case, the range would be from 0 to 12.5, well, 12.48. We're going to keep the 2 decimal places. So you might be asking yourself, well, what's going on? In all the other examples, right, we were looking at the range was either from a value to infinity, or if we look at the previous one, right, this one here, from infinity to a value. So why all of a sudden do both values, sorry, I'm jumping around here, do both values matter? Well, they both matter because now you've got some limitations to where this graph lives, right? Because when you're talking about the skier's height can't be negative, right? So the lowest possible height the skier can have is 0, and it's 0 in actually 2 places, not labeling that 0, but 0 in 2 places. It's on the x-axis in our graph in 2 places. Once at the start, before he jumps, or she jumps, I can't tell, and then once the skier's height at the end lands again, right? So when we're looking at our maximum height, that's actually halfway between our starting point and our finishing point. So at the halfway mark, we've traveled for 1.53, what is this measured in? Time in seconds. 1.53 seconds. So that's also where my axis of symmetry is. The equation would be x equals 1.53. So what would be the finishing height if we continued with this question? They say, okay, you started at 0 seconds and 0 height. You went at a maximum 1.53, that's halfway through 1.53 seconds, and you reached a height of 12.48. And then when you were done at the end, your height was back to 0, but how much time passed? Well, couldn't we just double the time? 1.53 times 2, and that would give you your end time. So the total time for the flight would be 3.06 seconds. Okay, we can test that with our graphing calculator. If you wanted to do that, second trace, you're finding your 0. Now, there's the one at the very beginning, we know is 0, 0, and then there's one at the end. So let's go to the end there. So we are left bound. Go right bound. Enter again. And there you go, 3.126. In this case, the rounding's a little bit different when we're looking at, but that's exactly what we're looking at, okay? If you got a question like this and you used your graphing calculator and got 3.126 here, or if you used your maximum point and you used the 1.53, either way I'd follow that through and see that that's where you got your answer from. So that's it for today's lesson. Thanks for joining me.